In this section of the build, we'll be pulling together the portion of the circuitry that turns the receive section off and on. So that portion of the circuitry is these three outline sections I've got here, plus the opto-isolator here. Now it's a bit hard to see how those sections interact, so I've redrawn the schematic just showing the detail of the receive off-on circuitry. So at the heart of the receive off-on circuitry is this opto-isolator. And this opto-isolator is turned on when transmitting and turned off when receiving. So when transmitting, this point here is pulled to ground. When receiving, this is effectively out of the circuit. So the various voltages are controlled by this resistor divider network here, and it controls both transmit and receive. So let's focus on the receive section first. So let's say we're receiving. When we're receiving, this is out of circuit here, and the voltage at this point turns these two FETs on. So this FET here, Q10, is effectively connected from the antenna to the receive detector. So when this FET is turned on, we have a straight pass from the antenna to the receive detector. In a similar fashion, this FET here, Q9, is turned on when receiving. And what this does is it pulls pins 1 and 15 of the FST3253 multiplexer, demultiplexer, which is used as a Taylor detector in this circuit. It pulls those to ground. And if we have a look at the truth table of the FST3253, you can see that when either pin 1, which is OE1, or pin 15, which is OE2, when either of those are high, effectively their corresponding portions of the multiplexer are disabled. So when they're pulled low, the multiplexer is connected through from the inputs to the outputs, and when the pins are high, the multiplexer is disconnected from the inputs to the outputs. So that's pretty much it for the circuit. Now, it does also include this point here actually goes to the base of a PNP transistor, which turns the transmit section off and on as well. So I'll cover that part of it when we get to the transmit circuitry. But for the moment, what we'll do is we'll pull this part of the circuit together, and then we'll go through the various voltages at these points just to confirm that they're indeed correct. So I've put together the receive circuitry. When I'd initially put it together, nothing was working, and I traced it back to I'd forgotten to install this resistor here between the microcontroller and the opto-isolator. After installing that, things started to work. So in order to test this part of the circuitry, I'm going to have to use the config SoftRock software on my laptop, and just panning around there. If you'll have a look, there's a PTT button here that you can use to simulate turning the transmitter off and on. So if it's depressed, the transmitter is on. If it's released, then the transmitter is off. Receive circuitry is on. So what I'll do to start with is probe point D on my schematic here. So point D, just moving the schematic back into vision here. Point D is right here at the top of the opto-isolator. So when PTT is depressed, this should read a high voltage, the opto-isolator is turned on, and when it's in receive mode, it should be off or a low voltage. So let's just probe that. Now I've got PTT off at the moment, and what I want to probe is this point right here, And you'll see there that it's reading a very low voltage, 0.0021, so close to ground. Now if I turn PTT on, let me just do that on the computer here, you should see that voltage went up to 1.17 volts. So that's confirming the opto-isolator is turned on with PTT turned on. So let's continue to probe around here, and the next spot that I want to probe to is point B right here. So the opto-isolator is turned on, point B should be drawn to ground. So point B should be at a close to ground voltage with the opto-isolator turned on, and point B will be at a separate voltage when this is out of circuit or it's turned off. So let's probe around there. Let me put my ground for my multimeter on here. It keeps flying off, so I've got to keep an eye on that. All right, we've got that there. So let's probe now to point B, which is a bit hard to see, but let me probe right here is point B. And you can see there with PTT turned off, that's around about 9.8 volts. So let me turn PTT on, that should go close to 0 volts now. Well, it's 0.102 volts, so that's close to 0 volts there. Okay, so now let's probe point C on the schematic I showed earlier. So point C is at the gate of both these FETs, Q9 and Q10. So when transmit is enabled, this voltage here should be low, close to 0, turning both these FETs off. When transmit is disabled or receive is enabled, this should be between 8 to 10 volts, turning both these FETs on. So let's probe that now. I've got PTT turned off at the moment, and point C is right here between these two FETs. So basically you can see there that it's around about 8 volts with the PTT turned off, so receive is turned on, so that means that's both those FETs are turned on. And then with PTT enabled, we have around about 0.08 volts, turning both those FETs off. So FETs are off when receive is turned off, and FETs are on when receive is turned on. So what I'm going to do now is test that the receive off-on switch is actually performing where when I turn transmit on, it's blocking any signal to the receive detector and letting through any signal with transmit turned off. So in order to do that, I actually I have to install an additional FET right here, which is turned on when turned on when transmit is turned on. So when transmit is turned on, this RX antenna comes from over here. So when this FET is enabled, this is pulled to ground, and of course any receive signal coming through is also pulled to ground. Similarly, this FET is turned off on receive, allowing the receive signal to go through to the detector circuitry. So in order to test that, I'm injecting a signal here, right at, just moving on to the schematic again. So right here is where I'm injecting that signal. So you can see I've got the receive turned off at the moment. Sorry, receive turned on at the moment. And if you have a look at the oscilloscope there, so here's my signal generator, injecting a 7 megahertz signal at 1 volt. And over on the oscilloscope is that signal coming through to the receive circuitry. So if I enable transmit, PTT, I'll turn that on now, and you can see that signal completely goes away. So that's basically the receive off-on circuitry completed. The next stage is to move to the receive detector itself. There's not much to do there. There's some toroids to wind. There's a SMD component, the FST 3253 multiplexer, demultiplexer to install. And so that's the next stage of the build.